Okay, I think we are going to get started. So, welcome once again, and thank you for being here today with us for the Greener Curriculum Showcase Series workshop, Green Chemistry and Sustainability Case Studies in the Classroom. And this space, the Greener Curriculum Showcase Series, is basically designed for educators to come together and learn more about a specific green chemistry resource. And today we have Dr. Tom Umile and Dr. Jennifer Tripp here with us to share with us about a new case study that they've developed in collaboration with Beyond Benign and ACS Green Chemistry Institute. And so, before we dive in, I want to just share a few housekeeping rules if I figure out how to do that. Okay. Yes. So live transcription is enabled. So if you want to turn yours on, you can click the CC button in your menu at the bottom of your screen. Also, the this session is being recorded and the slides and the recording will be sent after the event once it's ready. And just a reminder, this is a space for everyone. And so please do what you can to make sure that everyone feels welcome and included. Treat all people in the space with respect. This is our tentative workshop schedule for today. So as you can see, it's a very packed and exciting session. And Tom and Jen will tell us more about the different sessions when we start. Just a second to appreciate our current sponsors who make it possible to do the work we do at Beyond Benign, and also our key partners who collaborate and partner with us on a lot of the different initiatives we do to promote green chemistry education. And if you were not able to access the workshop materials I sent via email yesterday, this is a QR code to that workbook that will be very useful as we go through the different sections of the workshop. And so with that, I would like to introduce Dr. Tom Omole and Dr. Jennifer Tripp, who are professors teaching at the different institutions. They will do their own introduction, and this is me passing the mic to them. Thank you very much.
All right. Thanks, Monica. Let me see if I can do my screen share here properly. All right. Monica, how's that look? Slides working? All right. Thank you so much. All right. Hello, folks. Thank you for being here. As Monica said, Jen and I have been working with Beyond Benign and with the ACS Green Chemistry Institute to develop some tools to help folks build their own custom case studies for green chemistry. And we're going to share some of that with you today. So here's a brief outline. Monica shared this with you a moment ago, but a brief outline for you. Since time is short, we're going to move pretty quickly today, and we want to share a lot with you. But I do want to refer you back to the case study guide and workbook that I think Monica shared in the pre-workshop materials for much more detail. After some introduction and background, we're going to move into a more interactive portion of the workshop. So please don't wander away too far. We're going to need you to participate and share, because we think in the breakout rooms and in the discussions that you'll have, you'll learn lots from each other. And we hope that you'll walk away today with some pretty well-formed ideas for turning a real world example you have into a more formal case study that you could teach in one of your courses. And so to begin, let's just briefly talk about teaching green chemistry through case studies. Teaching with case studies has a pretty rich tradition in many fields. Case studies are integral to training future entrepreneurs, attorneys, physicians. It's not as traditionally common in science education, although that is changing. Many science educators use case studies. And I think one of the reasons they are is because there have been many demonstrated benefits to teaching with case studies. Just as one example, here was a 2015 study that looked at teaching two cohorts of students different topics in biology and chemistry using either traditional lecture or some interactive case study applications. And the data was clear that there was a significant improvement in assessment scores for the students who learned these topics through case studies. And when students were surveyed afterwards, the ones that learned through case studies attributed a lot of their learning. They perceived that the case studies played a big role in their learning, far more than just things like normal class participation or learning through textbooks. This is not limited to student perceptions. Faculty that have been polled about using case studies anecdotally report improved engagement from their students. Students generally just love seeing the real world applications. And so I think this is probably one of the reasons that the American Chemical Society now encourages folks to incorporate case studies into our courses. It's a expectation, a normal expectation that we're going to use case studies to teach students in our classes about green chemistry and sustainability.
Right. So this is, I'm Jen, by the way. Thanks everyone for coming. We are trying to, incorporate case studies into our classes for student satisfaction and student learning. And this is a graphic from a fairly recent paper that talked about ways to look at putting ideas of responsible chemistry into the class. So kind of thinking of bigger ideas, bigger ways of getting our students engaged and getting them to see the importance of chemistry in society. And one of the most important things here, step 3, as these authors called it, is to build a case study repository. So that's sort of what we're trying to do. There are some examples of green chemistry case studies, but we're hoping to have a lot more being developed with this template. So Tom, you can go on to the next slide. So some of you may be familiar with these case study books the first one was written by Mike Can in 2000, and then Mike and Tom, my co-host here, published a second volume in 2008. And these are really great case studies, though they are getting a little bit older, as you can see by the dates. They were all based on EPA Green Chemistry Challenge Awards, so they do a really nice job sort of presenting a problem and then an example of how green chemistry was used to help address that problem. There have been lots of case studies published in the Journal of Chemical Education, and you can see a few of those here, looking at ways that green chemistry is being used in different classes, Gen Chem, OChem, trying to kind of show students these examples of how chemistry can be used to address some of these problems. And then most recently, just at the end of last year, there was a whole series of case studies about soy chemistry that were published, and you can find those on the GCTLC as well. So there are case studies available. And actually, Tom and I initially proposed to make another volume of the real world case studies. And then once we started discussing this with the ACS and with Beyond Benign, we realized that actually it would be much better if we could give people the tools to make their own case studies. That way, everybody could be sort of empowered to tell their own stories, stories from their communities, from their societies, from their points of view, and share those stories with their students and also with other educators who might want to use their case studies. Next slide. Okay, so I think, is this still me? Yes. So I'm just going to kind of introduce this template that we have put together that is going to hopefully help guide you through a process of building a case study. And this template is not meant to be limiting. It's kind of modular, so you can use it in order as we've written it, or you can use just parts of it, or you can just kind of read through it for some ideas, or you can be very interested, very intent at filling in all of the different boxes. So use this as you see fit. I kind of want to start with that, and we'll keep saying it throughout. This is really meant to help you, and so you should just kind of take the pieces that help you and don't feel like you need to use all of it. So go ahead, Tom. Next slide. Right, is this slide 10? Sorry, I can't see the number. Yeah, good, okay. All right, so this is what we were sort of trying to think about as we were putting this template together. The first thing is we really wanted to broadly define the case study. So in medicine or in business or in law, case studies are really these very specific things, and they're used in very specific ways in the classes. But we really are defining case study as any real world application that you can think of that you want to present to your classes that involve chemistry and that relate chemistry to broader, bigger ideas in society or the environment or whatever. We also recognize that there's differences in the scope and the format. Maybe you just want to introduce a topic, so you need a 5-minute intro, or maybe you want to spend a week and a half in your class on something going really in depth. This template should enable you to develop those kinds of course materials. We also, in order to, follow good practices, we're emphasizing backward design. As you'll see in the template, we're going to start with choosing a topic and then writing learning objectives. And then from there, we'll talk about developing course materials. We want a sort of focused framework and guidance while also maintaining flexibility. Like I said, you don't have to use the entire template. You can pick bits and pieces that you like. And lastly, we wanted to make sure that whatever case studies people develop could be easily shareable. So we include part of the template that will help you get it into a form that's going to be readily shared on the GCTLC or with other people as well. So next up is Tom, I think.
Yeah, that's me. So as Jen said, we were trying to have a non-prescriptive guide and set of tools to help folks. So we were inspired by a lot of the literature on case studies and tried to identify a number of commonalities, things that weren't prescriptive, but just things that good case studies include in some form. And we identified them, and we came to put this list together, and we call this our template for a case study. These components are sort of a scaffold upon which someone could build their case study, essentially like a checklist, so you can map your case to different components as you build whatever diverse case study you and your students are going to explore. I think they help us move something from being just a mere example to something more refined as the teaching object. Just briefly looking at these, we have some essential components or things that we highly suggest should be a part of your case study lesson, and then some optional things that we realize are probably, they're important, but they're probably less important and might not be suitable for your classroom or just the topic that you're talking about. We could probably spend the whole 90 minutes going through each of these and their rationale. I'm not going to do that, but I do want to just briefly run through some of the essential components and why we chose them. First of all, a defined problem. We wanted students to know specifically why they're learning about the real world application, especially when we're talking about green chemistry. We could easily say something very vague like, this reaction is greener, but specifically what makes it greener? What is the challenge being addressed by the new technology? Or if it's something bad, not every example is going to be a positive. If it's a poor example, if it's a negative example, what specifically is bad to the environment or to human health about it? And then we're very focused on learning objectives. We'll talk more on these later, but to put it bluntly, case studies can be very complex things and have many aspects that go beyond the scope of our courses. I could understand why a student might get very distracted by a lot of the glitter and not know exactly what they're going to be expected to learn. So having well-defined learning objectives could help focus you as you make your case study, but also your students as they focus on their studying. To that point of complexity and things that may be beyond the scope of your course, having context and background and well-defined impacts, like what is the good and the bad that we're investigating here, could be something that your students don't often see in a science class. Sometimes we're very cut and dry, and we don't, just did you get the right number? So being very clear about what are the impacts to society, to people, to communities, to the environment that they might not be thinking about in their Gen Chem class, say, for instance. We also would celebrate the idea that a case study is more than just a straightforward lecture. that it should have some active component, whether these be formative or summative assessments, things that are done inside or outside of class. But we think those are pretty important to have some way for the students to engage beyond just watching a video. And then, of course, being good scholars, we should include references that would be helpful for us to go back to as educators when we're looking for more information, to our colleagues when we share our teaching materials, and also to students who might just think the topic is exciting and they want to get more information. So we have this template of components. Going forward. We have a template of components, but to help, we've also come up with a guide to walk the folks through the process, to help folks collect their thoughts, organize their thoughts. And as Jen pointed out, since we are proponents of backward design, we designed our guide that way, right from the bat. After we choose a topic for our case study, the first thing before we create any course materials or think anything about using it, we just think, what we want our students to be able to do with this information? What are our goals for them? And so that's really something that we do right off the bat. Once we get to our breakouts, which are coming very soon, we start doing the more interactive portion. We're going to walk through this process. So I'm not going to linger too much on this slide, but there is a process that we've offered for building a case study. And this comes with documents. I think these have been shared with you, but there's a user guide and a workbook. These are paired documents. They're in the same PDF, but they're kind of separate. The user guide, one example of a page from it is shown on the right, is more of a narrative that provides context, and we have references to some of the literature on building case studies. And then there's a workbook paired with this. To me, it's more like Mad Libs. Here are some guiding questions that you could just fill in the blank and just collect all your thoughts, get them down on paper. And these two documents together, we hope help folks, walk themselves through building all of their materials and creating a good, case study module. As Jen pointed out, our goal was for these things to be very robust and modular. So if someone wanted to linearly start on page 1 and chug through to the end, that would be amazing. But also if you want to float around, look at one chapter or one section before another, maybe answer one of the questions and then go do something else, that's celebrated too. We want it to not be prescriptive. Jen, I think this is back to you.
Yes. Yeah. So, what do you do if you need to know a topic for your case study? So, go ahead into the next slide. Oh, there we go. All right. So, so there's lots of different places that you can look for them. Like I said, there were the books long ago about the Green Chemistry Challenge Awards. Those are great topics for case studies. You can look at CNE News. You can look at the Nobel Prizes. You can even just look around your house, see what kind of household products you find, and maybe build a case study around those. If you are active in the teaching lab or the research lab, you can look for case studies around that. I don't know how familiar anyone is with the Scientist Spotlight Initiative, but these are little vignettes that highlight scientists, their work and their lives. So you can build a case study around one of these scientists. You can even look in the primary literature. I have a colleague who teaches a medicinal chemistry class, and he finds a lot of interesting examples in the Organic Process Research and Development Journal, for instance, and also the history of chemistry. Some students are super interested in history. You could, find some bit of alchemy that you could build a case study around. So there's lots and lots of places. Even just like the boxes of text in your whatever textbook you're using for your class that give the little examples. Sometimes those would make really great case studies as well. So you can go on to the next slide. So the idea that we're trying to do is you have a case study there in the middle. And the idea is that it teaches the course content while also illustrating the green chemistry and the sustainability. I mean, all of us have classes that are so full of content that we don't really have time to replace, the content that we have to teach with these ideas of green chemistry. So the idea is that you're still teaching the course content, you're still taking the time to do that, but you're building it into a story, a case study that will illustrate some of these bigger and broader ideas about green chemistry, about sustainable chemistry, maybe systems thinking, planetary boundaries. There's all of these ideas that are bigger that really interest students. It makes them care about the science that they're learning. But we're trying to not skimp on course content either. So both of these things have to work together in order for us to have time to do all of this in our classes. Next slide. So what we're going to do now is let you do some of the work on your own. So you can get into breakout rooms. And I think the process, the pages for the choosing a case study were included in what Monica sent out ahead of time. You can also go to the main template. That link was in the chat. That you can, look at the workbook pages there. So what you'll see on those workbook pages is just a few questions, kind of guided questions to help you generate an idea that you can use in your case study. Ideally, you want something, you don't want something really big, right? You don't want to say, well, I'm going to do a case study on batteries, right? Like there's so much chemistry there. You kind of need to narrow it down a little bit. But it also depends on your class and the scope of your class and, how much time you want to take for this. Like I said, if you just want to do a little introduction or if you want to go deep into the topic. So the questions that we'll have you address together, hopefully in your case studies or in your breakout rooms, you can talk about them or what real world chemistry do you want to use? What topics from your course are you going to teach? So what's the content you're going to teach using the case study? And then how are you going to relate that to green chemistry or sustainability? So I think Monica is going to manage the breakout rooms. So I'll pass it over to you.
Yes, the 4 breakout rooms have been created and it's open now. You get to choose which one you want to go into. And so there is one for organic, one for general chemistry, one for green chemistry, and there is one for everything else. So let us know if you have any questions, but you should be able to choose your room now.
We should say if you're having trouble generating an idea, we can come around and help you out a little bit. So we have some pre-made ideas.
I'm a little lost as to how to pick my breakout room. Sorry, it's been a while.
No, that's okay. If you click on the more icon, I don't know if you
Oh,
have that. Yes,
yeah.
perfect. There should be breakout rooms as one of the options.
Oh, okay. Got it. Thank you.
Welcome. Yeah, if anyone needs help finding how to get in there, let us know. All the conversations are happening in the breakout rooms. And so for those of you who are still here, do you need help getting in there?
We forgot to tell people how long they would have, or is it on the slide? Oh, it is on the slide.
Yeah,
Never
it's on
mind.
the slide. Yeah.
Okay.
Yeah. I think
Are
you
we
should
already
be able
behind
to
schedule? A little bit?
maybe a little
Oh,
bit.
no, not too bad, actually.
That's good.
Yeah.
Yeah. So you should be able to move around, like choose a room and do your stuff. I'll be here to hold the
Okay.
fort.
All right.
Yeah.
I'm going to go hit
Bounce
organic
around.
since that's,
Yeah.
I'm surprised there's only 2 in organic.
yeah, Gen Chem is quite big.
Yeah.
Yeah, Jetcan's big. All right, maybe I'll bounce in there. Yeah, and Monica, are you have a clock going mentally for
Yes.
when we come
Yes.
back?
Yes.
Okay.
Okay.
I
All right.
got it.
Excellent.
Thank you.
Thank you.
See you. That sounds good, Michael.
while we're coming back, I'll reshare my screen so that we have the slides in front of us. Monica, are we all back, or are we still waiting?
No, we are all back.
All right. Yeah, Jen, I don't want to step on your toes. You've been talking a lot. I feel bad, but I mean,
That's
how
fine.
was
I
your
was just
room?
gonna say we're seeing your notes page here, not
Oh,
the
oh
slides
no,
page. So
oh
I think
no.
you're
Why is
sharing
that?
the wrong one.
Yeah,
But yeah,
why did that do that?
I
Oh, there
popped
we
into
go.
two, and the
Oh,
discussions were
thanks.
really great. So maybe I'll call first on the organic room. Maybe could you both share, uh, 30 seconds about what you all were talking about?
I think we were talking about how busy we are and how much we have to jam into the organic courses that we teach. Um, I think the only thing we kind of went, the only direction we went in was looking at biodegradation of polymers, because polymers have antioxidants added to them to stabilize them. So uh, that was, you could go pretty deep in different directions. Like you want to teach about conformational analysis and or biodegradation, that's something that you could, and and polymerization reactions, condensation, that kind of thing. You could certainly bring that in, but and uh, I'll I'll let uh, I'll let my colleague um, Crystal jump in if she wants to, but I think we don't really know enough about these topics to really formulate something ourselves. So, but that's that's kind of the initial idea that we can bring into second year organic chemistry a little bit.
Great. And then I popped into the other room. Like there was some analytical chemistry and biochemistry people in there. So I don't know if anyone from that room wants to share a little bit about thoughts you were thinking of for topics.
I can share. My name is Janet Yang. I'm from the University of San Francisco. I'm Jen's colleague. I already had some stuff. Jen and I and another colleague had written a grant. And we started, as for people who are looking for inspiration, we started looking at the EPA Green Chemistry Challenge Award winners, and that was a good starting point for us. So, one of the things that we're going to be looking at is like, using these peptide-based pesticides and the structure of those and why they might work, et cetera, et cetera. So there's one idea, very embryonic stage.
Over in Gen Chem, we talked a lot about a packed curriculum as well. Does anyone want to share out? I think we had a volunteer.
Definitely. I'll jump in for the Gen Chem crew. Hi, everybody. I'm
Thanks,
Cody
Cody.
Edson, speaking from Bangor, Maine, here at Husson University. And we discussed in the general chemistry breakout, echoing Tom about all the content that we try to fit into a traditional two-semester curriculum for our undergraduate students. Usually they are freshman students straight out of high school. Personal experience, though, at our university, we're starting to see an increase in non-traditional students, so students that are coming back to get a new four-year degree after some time in the career. Moving away from that, though, I provided an example of how my team took a step back, and instead of focusing on specific examples, we first evaluated our audience. So provided that as a suggestion to look at your types of majors. So we're primarily here at Husson focused on health professional majors, pre-meds, biology majors, health sciences. So we use that audience to try and target specific examples, and we've found success with a variety of pharmaceuticals. It's very easy to go, here's the structure of ibuprofen, here's the structure of the new latest, greatest, GLP-1 inhibitor. Okay, let's break it down to the fundamental level. What is the molecular weight? Let's count up all the carbons in this pharmaceutical structure. So a lot of engagement there. A colleague, I forgot their name, forgive me, chimed in and shared that they have struggled as well with some other of the green chemistry principles in general chemistry, such as the atom economy. And so math still seems to be a conflict point for our early career or early education chemists and adjacent majors, and that Tom provided some examples of how he also used the Green Chemistry Challenge Award from the EPA as some great starting points that you can then branch out and see if there's other examples of green chemistry that relate to your students' needs. Thanks, everybody.
Thanks, Cody. I think we had one other breakout. I'm sorry, breakout room. Um, we've got the green chemistry room. I didn't have a chance to visit that one, so I don't have someone to put on the spot. I'll put you on the spot. Maybe perhaps after the next share out session. Monica, should we move on a little bit? All right. So let me advance my, sorry, my Zoom is acting up here. Advance my slides. I think this is next. So now that we have a topic, or at least are starting to think about a topic for something we might teach in our classes, a real world example that we want to form into a case study, it's time to think about what we want our students to do with that once they've learned from that example. I think one of the most common questions I'm asked by students is, what's going to be on the test? Sometimes that question comes from a place where the student hasn't been paying attention, but sometimes it's because I haven't defined the goals well enough. I take that on myself. Sometimes I like to, I should explicitly tell the students what those goals are, but even if I don't, implicitly I should know what I want them to know. And if I haven't defined that well for myself, the lesson kind of goes on its face. Sometimes the goal in my head, if I'm not doing this correctly, the goal has, it sounds like something that I have here in this red text. I'm gonna teach students about waste and reactions, and like that's a very malleable and nebulous goal. What do I mean by that? Do I want students to be able to recite the principles of green chemistry related to waste? Do I want them to be able to explain why waste is bad? Do I want them to be able to know what reagents like solvents contribute to the most waste in a reaction? Do I want them to be able to use and calculate metrics like process mass intensity that define waste in a quantitative way? Do I want them to be able to design a reaction that minimizes waste? Like, what does it mean to know about waste and reactions? To help with this, Jen and I thought about learning taxonomies. Many other folks have developed learning taxonomies. Perhaps Bloom's is the most common, but there's some other ones out there, such as Marzano's and many more. Taxonomies of learning are ways that folks have categorized, organized what it means to know something. From rote memorization to explanation to evaluation. And so we encourage, as part of the process of building a case study, to use these taxonomies just as inspiration to define exactly what you want your students to be able to do with the knowledge you're going to share with them. If you define your goals, your target well, in my experience, it makes your lesson much more refined, much more clear, much more organized. But it also helps the students to know like which of the moving parts do they have to pay attention to the most. And the answer might be all of them, but if you want them to pay attention to all of those moving parts, like you need to know that when you're crafting your lesson. Because if you're only focusing on if only one slide is the most important, then you kind of need to tell the students that.
Right. So I find the verbs that are available in those taxonomies to be really helpful when I'm sitting down to write learning objectives. And another kind of guideline that I found really useful are this idea of SMART learning objectives. And this it kind of tells you qualities that your learning objectives should have. They should be specific, like Tom was saying. You don't just want to say, I want them to know about reactions and waste. You need to like really specify what it is you want them to know and what you want them to be able to do. They have to be measurable. You have to be able to assess them on these learning objectives to make sure that they're meeting them. So you need something that you can, ask an exam question about or do a project about, or something that you can figure out if they're actually learning the thing that they're supposed to be learning or not. They have to be achievable. The students need to know that this is something they can accomplish, and it's not some pie in the sky thing. They have to be relevant to the class, to the material, and to the students' lives. I think that's important. That's partly why I think this green chemistry, when you can tie the chemistry content to real life stuff, I think the students find it a lot more relevant. And they have to be timely. They have to be able to achieve that objective in the time that you have in the class dedicated to that topic. And other things to consider are what prior knowledge or skills do the students have to know? So, if you're teaching organic chemistry, you expect them to know some of the things that they should have learned in organic chemistry. Hopefully, they haven't forgotten it and they learned it in the first place. And also, you should kind of at this point be thinking about assessments. When you're writing learning objectives, you're not necessarily writing assessments, but you need to, again, be thinking about how you're going to assess the students for these things. Next slide. All right, so the way we've set up the template for learning objectives is you can see the first page just asks a series of 3 questions. It asks about the prior knowledge, it asks about assessments. And then on the second page, we really get into writing the actual learning objectives. And you can see it's kind of in 2 parts. So we ask about the chemistry-focused learning objectives. These may be things that are on your departmental syllabus that you have to teach for whatever class you have, or things you've already written for your syllabus. These cover all the chemistry content. And again, because none of us has time to add in green chemistry, we really need to do these things at the same time. So then the second part here is getting those green chemistry and sustainability focused learning objectives, in addition to those chemistry content learning objectives. So for these, maybe you're focused on the 12 principles or the UN SDGs, whatever the bigger ideas are that you want your students to know. But again, they have to be something that you can assess. So if you go to the next slide, you can see a couple examples. This is a case study on electrochemistry that is also available on the GCTLC that we developed using this template. And it covers, it's based on one of the EPA awards for a process that makes an important monomer for polyvinyl chloride. It does it in a way that doesn't use Cl2. It doesn't make elemental chlorine or use elemental chlorine. So this would be for a general chemistry 2 class, presumably. And so there's 2 course objectives that the students need to meet. One is calculating standard cell potential using half reaction values. The second one is calculating the free energy of an electrochemical process from the standard cell potential. These are things that all the general chemistry students need to learn as part of the electrochemistry unit. But on top of that, we added a green chemistry learning objective where students will be able to compare and evaluate the 2 electrochemical processes using the 12 principles of green chemistry. So they go through the worksheet. This is an activity that is, maybe half of a class, half an hour or so, where they calculate the energies and the cell potentials for the standard process, and then for this new green chemistry process, or greener process, and then they can look at those 2 processes and they can evaluate them for energy use. They can evaluate them for the toxicity of the reagents and the intermediates that occur over the course of the process. And they can hopefully, see that the award-winning one is greener, and they can understand why, because they've done the math for it. So this is kind of what we're aiming for, is that they're still learning electrochemistry, but with that, they're learning the green chemistry. And it shouldn't take any extra time, course time, over just teaching them the electrochemistry. It's just that we've chosen the examples carefully and we've told them the story about it and had them think about it in a different way. So we're going to send you back to the breakout rooms now to think about some of the ideas that you generated in the last breakout room. And these are the questions that are asked in that workbook. What will my students be able to do? What specific skills should they be able to demonstrate? So again, it's not really, you don't know what's in their head. You have to be able to assess that. So they need to be able to demonstrate something, some skill for you in an assessment that will show them that they have learned what you want them to learn. what prior knowledge do they need, and then how are you going to assess that? And then, have a go at writing a learning objective. After successfully completing this case study, students will be able to ... and fill in the blank and see what you come up with your options.
Yeah, the
All right,
rooms
so
have
Tom
been
and I will
open.
pop around again and see how you're doing, but definitely bounce ideas off each other.
Tom,
Hey,
I have a
Michael.
crazy hey, I have a crazy idea that I wanted to pitch to you and Jennifer quick.
Sure,
Are you ready?
I'm ready.
So I'm teaching I'm teaching a sustainable polymers class this semester. It's a 2 credit, like 400 level class for students, obviously.
Okay.
But one of the things I was thinking about, hey, there's Jennifer too. Good. And you sent me this BCC thing. So I was thinking about using what I'm having students actually use your template to create their own case studies in groups. So I
That's
was gonna
Excellent.
great.
So when I'm trying to use current, I just got through first part. I mean, no. So this is. I mean, I can explain the whole thing later. But using your workbook the template, we're working on choosing papers and choosing things right now. So one of the things I was thinking about doing, Jane had just Wessinger just called me too, and because she's not busy, uh, I she's very busy. I was gonna also have her come help me, but try to get a bunch of case studies from this group of students, and maybe talk about that process at BCCE for your would that be something that'd be interesting to throw in there and just say like a little 15-minute tell you what
Yeah.
happened? I,
Yes.
I don't know
Yes.
what's going to happen yet, but something's happening.
It's okay.
Uh,
That's one
but
of
I
the
thought,
things that people have, like, when it sent out for review, people were saying that, this would be great for students to use. I think Tom's planning to do that too, right?
Yes.
This summer?
Yeah. I'm teaching a graduate green chemistry class this summer. I've always had them present on like
yeah,
real world examples and EPA Challenge Awards, but I've never had them. We have this tool now. I was thinking of turning that in. So I it'll be interesting to see what you do at BCCE. But I would love to. You and I should talk before then because I would love to learn from what you did because my class is in June, so
yeah.
that'd
I've
be
been meaning
great.
to email both of you, but I figured I'd just jump on here
Hmm.
today, and I knew I could get
Excellent.
you. So
Yeah.
okay, so
No.
I will forge ahead and keep asking questions, and as we go,
Yes.
and let you guys kind of get a frame for this. I'll submit an abstract by
Please do.
uh Monday then. Okay, cool. Me and Jane will do it together.
Yay.
Excellent. Yeah, that'd be
Yay.
great.
Good seeing you
Fantastic.
folks.
Yeah,
Looking
good to
forward
see
to
you
see you
too.
there.
I'm gonna go. I've read through all this. I've done this, so I'm feel good about it. This is
Cool.
awesome. So I want to make sure, but I appreciate
Thanks.
you both. Yeah,
Yeah.
All
I'm
right.
gonna
Thanks for being
All
here.
right. Thanks.
see you
Bye.
folks. Bye.
Right. Right. I'm gonna move to one of the breakout rooms.
You're gonna go check the green chemistry one?
Yeah, since someone was there before, and then I'll bounce back to Gen Chem. Monica, did I do that right this time? Thank you. I used to be good at Zoom, and I'm glad that I forget how to be good at Zoom. Those are, I don't, not good memories.
All right, welcome back, everybody. Let's see. Does anyone want to share? Whoops. Let's see. Tom, you went to the green chemistry breakout room, right? We haven't heard from them yet. Does anyone from there want to share?
Yeah, when I poked in, I think some folks were taking a bio break, so slipped away. Although I know there was when I walked in halfway into green chemistry, there was some great exchanges going on. So someone wants to share out from Gen Chem, that'd be great.
I'm happy to share out. So
Thanks.
the specific case study that I've been thinking about is I teach high school chemistry in the San Francisco Bay Area, and runoff is, I think, a really interesting case study for us. And I'm trying to shift my class to focus more on environmental chemistry. And so the specific topics that I'm thinking about are solubility and concentration, and then the lab skills related to that. And so a couple of things that came up in our discussion that were really interesting was thinking about as a kind of important step, connecting it back to the local problem and how to think about grounding students' work in real science practices. So something I was thinking about is, for instance, after completing the case study, the student should be able to calculate concentration in a variety of metrics and interpret concentrations in, let's say, like parts per million, milligrams per liter, or molarity. And then also something that came up was alternatives analysis as an important component of green chemistry. So if students are, say, making a recommendation of what to do based on the data they find, can they be deciding between and picking an alternative to recommend from the current situation? So those were some of the things that came up in our discussion.
That's really great. Thank you. I went to the organic, which we got a little bit off topic, but I'd love to have somebody from there share. We were talking a little bit about how to get more systems thinking into the organic class and how to kind of drag that through the whole curriculum by using specific examples. So I think Cody and Ashley, maybe one of you could jump in and share. That would be fantastic.
Sure, Jen, I'll jump in. Yes, I jumped ship from the general chemistry to the organic breakout room just to talk to more people and get some more insight. And it was a great conversation. Myself, Ashley, and Crystal. I jumped in. Ashley and Crystal were discussing in organic chemistry, identifying structures and relating them to toxicology, for example. So identifying that quaternary ammoniums are neurotoxins and providing examples of that, which kind of led us into our discussion of system thinking and branching out, what is the bigger picture of chemistry, making it more applicable. And I shared about how here at Husson, my team and I are trying to work in the organic chemistry curriculum, stepwise introductions in examples of systems thinking and life cycle analysis. So we are piloting this semester teaching in the general chemistry curriculum the first 2 weeks focusing on green chemistry and system thinking so that students are introduced to that immediately. And we're hypothesizing and hoping that when they transition into organic chemistry next year as sophomores, when we reintroduce that system thinking module, we'll be able to say, hey, you saw this last year in general chemistry. We kind of just touched the surface level. Let's now go deeper, refresh our memory on what the systems thinking is, apply that to the
So I think we lost him. All right. Well, hopefully Cody will come back to us. Does anyone from the general chemistry group? Oh, there he is. Sorry, Cody, I think you got cut off a little bit, but
Oh, I apologize. I didn't even
yeah,
realize that everything was good on my end. I finished
yeah,
everything I had to say if Ashley or Crystal wanted to add anything to that.
okay. Um, if not, we can move on to the Gen Chem group. I know that was a big group in there, but if anyone wanted to share out, that would be, or no, we heard from Gen Chem. Who haven't we heard? Oh, the other group, the biochemists and analytical chemists and various people there. Does anyone want to share anything you all talked about learning objectives or wherever your conversation went?
We're all like teaching in very different areas, but I can share a little bit about what we talked about. So, um, well, one, it was very helpful because I had a lot of really great suggestions from people on different ideas on how to approach thinking about analytical chemistry and different options of thinking about how to connect like what students are learning in an intro analytical course to green chemistry metrics as well, and sort of comparing and contrasting different methodologies. We also talked about in the various courses we're teaching, we have different like time lengths. So in like intro analytical is much more like limited in terms of how long we can do a case study, but another member was talking about how she had like, a few weeks to teach a particular topic. And so thinking about how the learning outcomes can sort of fit over a broader space of time and how to sort of think about scaffolding that work across many weeks of teaching and ultimately sort of leading to a student project. Um, I'm not sure. Did I miss anything? Anyone else want to jump in?
No, I think that was great, Rachel. I think we didn't get to the point of crafting our learning objectives, but I thought it was really helpful before we went into our breakout rooms to think about, just drawing on learning outcomes or learning objectives that we already have for specific units of study in our classes, and then just seeing where you can kind of double dip, like making it explicit that it's not just teaching chemistry chapter 4 2.7 but it's also this green chemistry principle. So I love that idea, and I think that can help, especially in multi-section courses, kind of quell the reticence of people who are not incorporating or trying to incorporate case studies, like that it can feel like you're like shortchanging your students because you're just spending all your time talking instead of like doing the real chemistry. Maybe I'll don't have that. I'm lucky I don't have that, but I know I've talked to colleagues that say there can be a tension sometimes, right, in trying to add this to your curriculum.
Yes, that is definitely one of the things we were trying to address with that, is letting people use their existing learning objectives, but hopefully kind of build this in these ideas of green chemistry, sustainability, systems thinking, build that in more easily without feeling like it's, completely changing your entire course. Okay, I think we're moving along to the making materials. How are you going to take these learning objectives that you'll write and turn them into course materials? So I think Tom is going to cover that.
Sure. So that now that we do have our topic and our goals, it's time to really think about how we're going to deploy our case study in our class. In many ways, this is the most personal part of the process because it relies not just on your learning objectives, but it relies also on how, where, and for how long you want your class to engage with the case study. So this could be a large thing that becomes a multi-day project. It could be a small component of one class meeting. It could be something done outside of class. So it's really personal. What your case study will look like in practice will be sometimes very different from what someone else is doing. And that's to be celebrated. So in the interests of time, rather than kind of walk through the process, since it's so personal, I thought I'd share with you two diverse examples of different sizes and scopes of case studies that I've used in two different classes that I teach. So one case study that I've created for targeted for an organic chemistry lab for majors is a case study on green metrics. This is based around Merck's redevelopment of their synthesis of the antiviral drug molnupiravir that reduced a lot of the waste they generated in the first generation process. This lab has a weekly recitation for 50 minutes, and usually as a part of that recitation, students have some sort of assignment, something to do beforehand. So I envisioned this case study to be something that students engage with through the recitation portion of the class. I wrote a short document that describes some green metrics like E factor and process mass intensity. I describe Merck's synthesis. I present both of them, the first generation and the redeveloped one. There are a bunch of reactions that even the sophomore organic chemist could appreciate, so I drew attention to those. And that narrative is a pre-reading, so I expect the majors to read that beforehand. I've also created an 11-slide deck, which is about 15 minutes, which kind of touches on the same topics, presenting green metrics and looking at the two conflicting syntheses. And some years I would record that as a video, but if I have time in class, I take up a couple, maybe 15 minutes in class. The capstone, the meat of the case study is an activity that we do in recitation where I give students two textbook syntheses of the same compound and have them practice with me there, calculating the percent yield of the reaction, the E factor, and the process mass intensity, PMI. And then we have a really good debate over like which of these two syntheses are better. And one of them is high yielding and one of them is very low waste generating. So the students argue over like, do I want the high yielding one or do I want to avoid waste, which leads to some great debates in class. This doesn't have any sort of any sort of formal summative assessment. However, from this point forward in the lab curriculum for the rest of the semester, I expect them on their lab reports to calculate PMI along with their percent yields. So they get to multiple avenues of practice. So this was kind of a larger case study to me because it takes up a class period and then there's repetition. On the other extreme, in my general chemistry class, I often use mini case studies to introduce topics. So when we're going to cover a new chapter, I'd like to give the students context. Why should they care about it? And I've been using green chemistry case studies to frame the why should you care about it. So 5 minutes to frame the topic, and then we revisit it at the end of the chapter. Here's an example of a mini case study. It's based upon a Green Chemistry Challenge Award that was given to a team at the University of Pennsylvania and down the road. And it was for a new technology to help recycle some rare earth elements from electronics waste. Basically, they developed a bunch of ligands that combined to ions of different sizes. And so that's how they fish out and leach out the ions, the metals of interest. And so when we're going to talk about the periodic trends chapter, I spent about 5 minutes at the start of class talking about this technology and how it can discriminate amongst different metals based on their ionic radius. And then we go forth and have a chapter for a couple of days on periodic trends and learn about electronegativity and ionization energy and ionic radius and atomic radius and all that. And then at the end of the chapter, we come back to this, usually in recitation, and I point out that, hey, that list of lanthanides you may not be able to see that we started with at the beginning of the chapter, like they all have different sizes and there's a trend to them. And we have a discussion about like why are these things getting smaller as we go across the periodic table. So This doesn't take up much time. It reinforces a point that they're already learning. It gives them some context for it and some real world applicability. And so, as we're kind of rounding third base here before we're done, we would like to pop back into breakout rooms one last time, so folks could kind of talk about the things you've been talking about, and maybe flesh out an idea. How do you want your students to engage with this? Do you want something big? Do you want something small, in class, outside of class? And once you've decided that, like, what things would you need to make? For me, this is the fun part. Sometimes finding the idea and linking it is hard, but once I know what I want to do with it, I just love seeing these things come to life. So if we can revisit breakout rooms, Monica can open them one last time, and we'll spend about 5 minutes so we could come back and close and get you off to dinner. Those of you on the East Coast like me, and we'll share out. So thanks.
I think Jonathan has a question.
Oh, sure.
I do have a quick question, but it's sort of maybe a bird's eye view. Hopefully it's not too loud because I'm in a coffee shop right now. So I guess as you guys were looking through the different examples of case studies in the literature, obviously a lot of these are looking at like historical things that have happened in industry or historically. So usually there's what was the problem at the time and then the solution that came about. When you were looking at these different case studies, was there a certain percent that framed them as you give the students the problem and the solution, and then you have them kind of walk through what was done and connecting to the core concepts? But were there other ones where it was framed as, here's the problem, okay, you come up with some ideas, we'll come back, share, and then I'll tell you what the actual solution was that the company or whatever ended up coming up with. So how often, I guess, were those case studies more open-ended versus more like kind of guiding them? And I guess maybe that depends on the level as well. Maybe more advanced courses, you might give them more flexibility to decide and come up with some ideas, which might be more how they would actually have to approach it in a if they were working for one of these large chemical companies or pharmaceuticals, whatever. So just kind of curious if there was those kinds of different formats that maybe those case studies used.
Yeah, I think some of them, like you said, it depends a lot on the level. And I think there were some where people, like, especially in the lab, they might focus on, say, solvent choice or catalyst or something kind of really targeted and let the students do a little bit of research and come up with what they think is the best option for something. There weren't too many open-ended ones like you would maybe see in business classes or something like that. And I think it's just because the students need a certain level of chemistry knowledge to tackle these chemistry questions that they probably don't get until their third or fourth year. So hopefully, I think more of it's, you present the solution if there is one, or you at least present the problem and try to get the students to understand the chemistry that's there more so than trying to create it themselves. But you can certainly do that in a higher level class, I think.
Yeah. And Jonathan, to your question, I don't think I don't have a firm number on the what flavor of case study is most common, but I will say in our research that some folks are very adamant about and very prescriptive about what a case study is. There are some folks in the literature that think a case study, as you pointed out, is a historical thing that we should have here's the problem, you all debate what we should have done, and then I'll tell you what happened. Some folks are like, that's how it has to, like, that is, if it's not that, it's not a case study. And then there were some folks on the opposite side that said that it needs, here's what happened, here's what was done, and then we just talk about the process. And there was even a third case where there are some folks that we don't even talk about what actually happened, or maybe we're talking about something that hasn't been solved yet. Maybe it's some pollutant. So it's just supposed to be a open-ended question to wrestle with. And that's, I think, when Jen and Monica and David and I were working, like, we wanted to avoid being prescriptive like that, because some folks might want that open-ended debate in their chemistry class, and as Jen pointed out, for Gen Chem that might not be appropriate. So we wanted to make sure we included. We wanted to respect those traditions in the template, but we didn't want to require any of those three extremes because we don't want to scare people away. Thanks for the question. Great question.
Do you want to pop into the breakout rooms? And then we still
How much time do we have, Monica?
We have 6 minutes, so there's still a good amount of time.
Okay.
Yeah, for those still here, this is still the breakout session. So if you can join and participate in the conversation there, that would be great.
I'm going to join one of the rooms. Monica, if you want to, you could always, in the intro, I'm looking at the clock. I just want to make sure we end on time. So if you wanted to pull people back a little early, because I think Jen has like 2 slides to wrap us up. So
That sounds good. Yeah, and I have 2 slides too.
All right. I think she'll be back.
We are all back, Tom and Jen.
All right. So I know there were some good conversations. We had to cut those breakout rooms a little short, but I do want to save maybe a minute or two for some sharing out. So I know I arrived to the Gen Chem room late, and there was some great conversation going on. Um, Folks want to maybe give us a 2 or 3 sentence summary of what you were wrestling with? Or from perhaps the organic room. Jen, I know you were popping over there.
I was actually in the other room,
Oh,
which had some good conversation as well. I don't know if anyone wants to share. We weren't really talking about course materials too much, but
Yeah, I can jump in for the organic room. So it's just me and Crystal again,
okay.
and we're organic
thank you.
chemists, so we got off topic as usual. But I think based on we had Cody in our room last time, and we talked about systems thinking as a strategy to teach green chemistry because you can't just focus out on one thing. So one of the things Crystal was bringing up was, and which I noticed when I taught green chemistry, is students get really fixated on one aspect. So there's 12 principles of green chemistry. And for me, my students got fixated on the whole idea of it's from a renewable resource and it's biodegradable. They were the only two things that seemed to focus, that seemed to inform every decision they made. And then Crystal was saying that with her students, it was all about catalysts. Does it have a catalyst? Yes. Oh, it must be good then. So I think in terms of how the students engage with the case study, I think before you even do the case study, you've got to have an idea about systems thinking because students tend to fixate on one thing. Humans tend to fixate on one thing as well. And then I think Crystal mentioned as well, and I've seen it as well. You might spend a lot of time developing the case study, and this is developing into a question. And then the next day you see it up on, Course Hero or one of those sites, and all the answers are there, and you're like, well, why did I bother putting this answer in? So maybe going back to the facilitators, how do we navigate that? Oh, and AI as well. How do we navigate the use of AI? So sorry, my assessment has come into two questions. Apologize for that.
Great. Thanks.
That is quite a question for 3 minutes left. I think we need a whole new symposium on how to use AI or not use AI. Yes, but as far as the other about sharing it, I think that actually kind of segues nicely into the next part of our talk. If Tom wants to
Yes.
go on with that, sharing your course materials. So I hope that all of you have found the Green Chemistry Teaching and Learning community. If you haven't, please go find it. And one of the things that we've included in the template is this cover page that you can see here on the screen, which kind of lists succinctly things that will be useful for other people to find your case study and hopefully use it. So the title, some keywords, the learning objectives, and so on. So hopefully, as you develop these case studies, you will share them and post them on the GCTLC. And what's really nice about this is that, let's say Tom develops a case study and posts it up there, and I say, oh, this is great, but I'm going to change it. I'm going to adapt it for my class, and here's a new worksheet or here's a new set of problems to go with it. Then those can be, I can post that up next to his case study and say, here's my adaptation. So I don't know that there's a way to keep the answers from going on Course Hero, but if people keep using these and developing the new questions with new answers, maybe we can stay a little bit ahead of that. And then if you go to the next slide, just a few more announcements. Tom and Monica and I and a couple other people are organizing a symposium at BCCE about case studies. So if you are going, please come and see us. The abstracts aren't due yet. So if you have a case study, if you're using case studies and you want to submit a presentation to be included in our symposium, we would love that. So please consider that. The abstracts are due this weekend. So you don't have too much time, but if this is something you've been doing and thinking about, we would love to include you in our symposium. And even if you just want to come learn more about it, please come and attend. And the other thing, maybe Monica can say a little bit more about this, but there is a call for case studies on the GCTLC that Beyond Benign is hoping to encourage people to develop these case studies and submit the case studies. One nice thing about posting on the GCTLC, they are peer reviewed. You do get a DOI and you get full author credit. So something you can list on your resume or in your tenure and promotion materials and so on. And I believe there's a small stipend that you can earn. Is that right? I'll turn it over to Monica to say more about that.
No, the stipend period is over, but yeah, we hope you all will be encouraged to contribute to the collection, which I have linked in the chat. So, and you should have received that email from me to provide your feedback on today's workshop. We really appreciate those feedbacks because it helps us to improve each session that we host. So thank you all for being here today, and over to you, Tom and Jen.
I think this was the last of our slides, Monica, so we're actually going to turn it back over to you. As I'm doing that and stopping my share, I just wanted to comment. I wanted to thank everyone for being here and for participating. And I am excited by the energy and the interest that I'm seeing from the community. I always do. I love the screen chemistry education community. But I just, well, as an aside, I noticed that so many folks are wrestling with the same challenges, the same problems, the same blockers. And so let's lean on one another. Let's learn from one another at these conferences, on the TLC and whatnot, because we're facing the same issues. So let's, if one person solves them, share your solution.
Yes, I just put my email address in the chat. I'm happy to pursue these ideas more with anyone who wants to do so. I'm assuming Tom is probably typing his in right now. So definitely keep in touch. And I'm excited to see some of you again and meet some of the new people that were here. And it's the more we can grow this community, the better. So thank you for coming.